Oh, hello. Welcome to Good Science. Well, are we going to have some fun today? We are going to figure out and learn, does air take up space? Our objective today is to demonstrate that the air in the atmosphere definitely does take up space and help us better understand something that's invisible in a gas. In order to do that, we'll be using water, air, and a clear bowl or glass bowl of some kind, or a plastic container works, something that you can see through, because this is not magic, okay? And so we want to be able to prove with evidence that air does really take up space. We'll need a couple of file folders cut into the size that can fit over the rim of your cup or glass, okay? And you'll see why it should be a thicker cardstock. A ping pong ball, a balloon, any size, and I'm going to use a balloon pump for my balloon, but blowing it up works fine too. So why don't we pause and let you get your materials together, and then come back and we'll get started. Okay, I forgot to mention with the materials, and you can gather them. Stop the video anytime to gather them, but some paper towels and computer paper might be helpful. I'm going to grab a little catch basin that I will be using for one of the activities. I hold up this paper cup and I ask you, what is in it? Well, probably nothing. It doesn't look like there's anything in there. So I'm going to take the cup and I'm going to ask you to think about what will happen if I take this cup, put it into the water, and push it all the way down to the bottom. So you think about that, okay? Make a prediction, and let's see what happens. I don't know if you could see that or not, but the cup has droplets on the outside, but it is dry on the inside. Now, you might not be able to tell this from my view, but I can tell you that it's dry. The cup stayed dry. What could have been in the cup to keep it dry? Air. But to prove that to you, I'm going to take a dry cup from the outside, a totally dry cup, and I'm going to put a ping pong ball in the water. Okay? Well, what's holding up the ping pong ball? It's water pressure. Again, I want you to make a prediction. If I take this dry cup and I put it over the ping pong ball, it's floating on the top right now. But if I push this cup to the bottom of the container like I just did before we put the ping pong ball in, I'd like you to predict what is going to happen to the ping pong ball. Will it float on the top? Will it kind of move to the middle, or will it be on the bottom? Okay, I'm going to do this again. I'm going to take my dry cup or glass. Make sure you've dried it if you're using the same one. Okay, I am going to put it over the ping pong ball, and I'm going to push the cup all the way to the bottom. Can you see the ping pong ball? Okay, it's staying there on the bottom, but what is holding it there? Again, check your cup when you take it out straight up, put your hand inside, and you'll feel that there is no water. You get droplets along the outside, but really inside is dry. So the only thing that could keep that dry would be air. So does air take up space? Well, it seemed to me that it did when we did this with our ping pong ball, okay? And the air pressure filled the cup with air and kept the inside of the cup dry. Okay, let's do one more. Try to continue to help us with this. Now this one's tricky, and as many times as I've done it, sometimes I have to do it over and over again. First of all, you have to make sure that your hands are dry. Okay, everything you use for this should be dry. You're going to fill a dry cup to the top with water, pretty much to the top. I'm going to move this over here. Now this one can get messy, so make sure you're over the sink. I'm going to use this little bucket to help me out, but make sure it's over the sink. And again, don't be disheartened. Remember, in science, it's okay to be wrong. And if this doesn't work once, we'll try it over and over again till it does. Okay, so I have the water in the cup. I need to put my card over the top so that my hand fits over the rim. And then in a quick motion, I'm going to turn the cup upside down. No, that didn't work for me. Like I said, we just keep on trying. I need another cup. Okay, we're going to try this again and see if I can get it to work. Again, everything has to be super dry. And I want to make sure, even though we haven't used this cup, that it is super dry. Try filling it to the top. What I'm having a problem with is I don't have a glass. That's weird to say, but everything's gone to plastic now. I don't have a glass. My plastic cup is unsteady. Let's give this another shot. Okay, I think it's my cup. This isn't the same one that I've used before. So I am going to leave that challenge with you because I do know it works. When you turn the cup upside down and you move your hand away slowly from under the card should stay attached to the rim of the cup. And it's simply because that the air pressure that came in between the water and the cup, when I put the card on it, it trapped some air in there. But this is something good for you to keep occupied and just keep trying it because I do know it works. Now, another activity you can try is to take some paper towel and stuff it into your dry cup. And I'm going to push this paper cup, just like we did earlier. I'm going to invert it, and I'm going to push it straight down into the water. Now, based on what we have seen so far, do you think this paper towel will stay dry, or will it get wet? We're going to check it out. Let me see if I can get this out without touching anything. And yes, paper towel is dry. So the only thing it could be is that when I place the cup on the water, I've got air in here, air in my cup. So when I push it down in the water, the inside stays dry. This is called pressure. And the reason that we're going through all this is you're going to begin your study of the atmosphere, Earth's atmosphere, and how it affects weather. And because of that, we're going to take what we learned today and apply it to Earth's atmosphere. Another demonstration of, fun demonstration of air taking up space is if you have a balloon of any size and it's not inflated, well, that's no fun to play with. So what do we have to do? We have to find a source of air. I'm using the pump, but you can just blow it up with your mouth. So what's happening here is air is being pushed into the balloon. Now we know air has pressure because it's keeping the balloon inflated. The pressure of the air is inflating that balloon. And as you think about this in everyday life, if you have a flat tire on your bicycle, what do you need to pump it up so you can use it again? Air, compressed air, but air. Okay, air takes up space. I don't know if you've been, I'm sure you've been have ridden your bike around the neighborhood. What if it's a windy day and the atmospheric, the air in the atmosphere is blowing in your direction? We got a strong wind and we're riding right into it. Does it slow you down? Can you feel the difference? Then if you're riding on a day when there is no wind, you're still passing through the air. But when it's not blowing in your face, you don't realize that there is air pressure all around you. And so with that, we're going to wrap this up. Okay. And we're going to, I'm going to leave you with this challenge. Okay. I'd like you to write a statement based on evidence on what you learned today that proves that air takes up space. Thank you for watching. If you like what you saw, please consider subscribing to this channel and show your support by sharing what you've learned on our Facebook page. See you next time.